So here we are on question 3. It is a statistics question. It's one I hope that everybody will be looking to do because if you if you master this one, it really is a nice quick question for you. Grania wants to see if there is a relationship between the outside temperature and the time taken to dry her laundry. She probably suspects that there is. The following data was collected over a 10-day period. Complete the table below by locating the data in the diagram. So I hope this is relatively straightforward for you. We have the temperature axis down here, and the time axis is your kind of vertical axis. So your horizontal axis is the temperature. One thing to take into account is that the units on the horizontal axis, it's increasing by 1 each time. But on the vertical axis, it's increasing by 2, or the gap is 2 each time. So you just have to take that into account. So if I was to look for, if I just try to identify this guy here, just to start off, this would be 41, 42. So on a day where the temperature is 42 degrees, how long does it take to dry the clothes? Well, if we look at this, it's halfway between 14 and 16, which of course would make it 15 degrees. So that ties up to this point here. So then when we're doing the 32 degrees, okay, so 32 degrees is going to be here. So that's that point. And when we go across, then it's 2 units up on the vertical axis. So like this is 31, this is 32, but here we got to be just careful. This is 22 and then 24. So when the temperature is 32, it'll take 24 minutes to dry. With the second one, we have to be more careful because there's 2 of them here at that temperature of 28, so 25, 26, 27, 28. So we go up and we have 2 here. So let's just be kind of very careful here. This goes 26, 28, 30, 32. So the upper one is, this point here would be 28 degrees, 32 minutes. And the lower one is 28 degrees and it's 29 minutes. So we have a look across here and we do locate the 28, 29 here. So that's the lower one taken care of. So therefore the upper one is 28, 32. So, when you look at it afterwards, easy enough, but you can see how mistakes could get made there. We then have to draw the line of best fit onto the graph above. So the line of best fit is drawn in this way. It's drawn in such a way that, roughly speaking, you have about half as many dots above the line as below the line, and they're as tightly packed to the line as you can get them by drawing the line of best fit. You can, if you wish, go off and find the average of the x's and the average of the y's, in this case the average of the temperatures and the average of the times, and use that as a kind of a point for it to go through. That's fine too. But there it is, drawn by eye, absolutely fine. And between A and B, you now have 10 marks. You're asked then to find the equation of the line of best fit. So to find the equation, you can use your calculator. Now, we know there's kind of 5 different calculator types on the go. There's what I would call the old Casio, then the Class Whiz Casio, and then the new Class Whiz Casio. And then there's the old Sharp and the new Sharp. So there's different ways to calculate these. But if you have your equation in the form of y is equal to bx plus a, which is how it's described on some of the calculators, you calculate a to be your coefficient, or your y-intercept. So you have to be careful with it here because it might look to you like it's going to be 44 there, but of course it's not. The part of the graph we're seeing here isn't going as far as the origin, so you do have to be careful there. So A is 60, B is minus 1.13 when you round it to 2 decimal places. That makes sense, doesn't it? Because it's a downward sloping line. So you can do that. Okay, so that can be you can use that to form your equation if you've done it on the calculator, but you can do it on the graph. And how you do it on the graph is you calculate the slope, because what do we need to find the equation of a line? We need the slope and we need a point. So you can get any 2 points on the line. So for, in this case, like, you can choose, even if I wanted, I could choose that point there. And even look, this point here, because there are 2 of the points from the original data and the line is pretty much going through them. Okay. Or you can, if you wish, you can say, okay, I'm going to take kind of whole numbers on the x's, right? So if we go up from 44, we're going to find, so we go up from 44 and we're going to have a point here, 44.15, okay? 44.15. And then if we go the other way, actually, if I look at this, actually, this point up here, it's a bit of a coincidence, isn't it? Actually, no, I was wrong about that one. So let me erase that one there. If I go up from here, this would be a better way. If I go up from this one, I'm at a nice easy point to identify 1544. So 15 on the horizontal axis, 44 on the vertical axis. And instead, if I choose this last point here, I'd have 45, 10. Okay. So those would be my 2 points. And they work out to be nice, neat points to use. So I was saying that was 44.15, but I wasn't quite right about that. So I can then get my slope. So when I calculate my slope using my y2 minus y1 over x2 minus x1, I can calculate my slope. And of course, these are my points that I'm using, my x1, y1, my x2, y2. And I calculate my slope to be the minus 1.13, which turns out to be the same here. And then I can just choose any point. So I'm going with this one down here. This will be my x and this will be my y. So my y minus 10 is equal to my slope minus 1.13 times x minus 45, multiply it all out, bring everything over to the right-hand side, and I get a line which is very similar to what I have here. So if I use the calculator, I get y is equal to minus 1.13x plus 60.74. If I use my calculate my slope and find my equation, I get y is equal to minus 1.13x plus 60.85. So if your line looks something like that, you're going to get the full marks, right? And if you check on the marking scheme, you'll see the kind of boundaries for what's acceptable. And you kind of know yourself. And where, that was worth 5 marks. And where your accuracy of your line becomes clear is in this next part. Well, coming up in the part after this, state the correlation coefficient correct to 3 decimal places and describe the association between the 2 variables in terms of direction and strength. Now, you got to be able to calculate your correlation coefficient, so important. So I have videos there on the website about how to do it, but the correlation coefficient is R is equal to minus 0.972, correct 3 decimal places. Now, again, because there's the 5 different calculator types, there's 5 different kind of sets of inputs required. So you gotta make sure you know the one for your calculator. Because it's a minus, it is a negative correlation because it's close to -1, right? -1 would be a perfect negative correlation. But in this case, it is a strong negative correlation. Okay. And so what that means is that as the hotter the temperature, the shorter the time required to dry the clothes. So I've been inclined to include that as well, just to be sure. The temperature on day 11, so the 11th day, is predicted to be 17 degrees. Okay. Use the equation for the line of best fit for part C to predict the time Grania should expect her laundry to dry in on this day. And is this prediction reliable? Justify your answer. So depending on which formula you used, you're going to be filling in the 17 in for that's your input, and you're going to get an answer. Now, this answer here shows you the accuracy of your equation that you formed in part C. So it can, depending on how close you are to 41.53, you can judge how many marks you should get for the previous part. If you're miles off, that means your line is poor and you're probably going to get low partial credit. And if you're closer, you get higher marks. So At 17 degrees, you get 41.53 minutes. And so that would be this point here, okay, based on your line of best fit, based on your equation, okay? And so you can use the line of best fit and go up from 17, or use your equation, and in either case, it'll bring it to the same point. Now, you can interpret your answer differently, right? Okay, so this is a controversial one. You can say, no, the result is not reliable as it's outside the range of our known variables. So what we've recorded so far, where our lowest temperature was 21. And the relationship may not be linear as the time drops. So we have a line of best fit for the range of values that we have between the 20 and the 42, but lower than 20 and higher than 42, it might not be a linear relationship, okay? However, we will accept as well that if you say, yes, this is reliable because it's on my line of best fit, it kind of, connects in with all the other data that we have, that will also be acceptable for full marks if you justify it in the right way. So if you have the right answer kind of plotted on the graph and you make your case that it's on the line of best fit so that it makes sense that that linear pattern will continue, we would accept the marks there as well. Okay, so some people will have liked that question a lot, and other people might have found some bits a bit testing, but hopefully not too bad. So that's question 3 done. We're on to question 4.